Hello, everyone. First of all, wishing that you are all doing well and that you're healthy. This is the second part of the practice questions 11 through 20, as promised last week. The quiz will be based on these 10 questions. So, question 11. A monument is shaped as a frustum. So, a frustum is basically a pyramid that does not have the top. Like you can see here, they took the top off the pyramid. So the brown shaded region is the frustum with a square base length and width 50. Okay. The top of the frustum is a square with a length and width of 10 meters. Let's not forget the units. The black point is the projection of the apex on the base. Now, the apex means the height that falls directly on the center of this bottom square. First thing they ask us is to show that h equals 11. So they want us to show that this equals 11. Okay, so whenever you cut the top off a pyramid, that is a square base pyramid like this one, then you're going to have a situation of proportionality. So it turns out that h over 10 from the top part of the pyramid is equal to the height of the pyramid, 55 over 50. Therefore, that means that h is equal to 55 times 10 divided by 50. Now, if we simplify this, this is really 55 divided by 5, which equals 11. So we've shown that h is equal to 11. So this was part A. For part B, they want us to find the volume of the frustum. Now, the volume of the frustum is going to be the total volume of the pyramid minus the volume of the small pyramid, so to speak, the little pyramid on the top. So let's first recall the formula for the volume of a pyramid. The formula for the volume of a pyramid is, well, not area, volume. So volume of a pyramid is equal to 1/3 area of the base times the height. So in this case, we're going to have to do a subtraction. So we're going to subtract the major volume, so 1/3 area of the base, which is going to be 50 times 50, or 50 squared, times the height, which is 55. So that would be the whole pyramid, but from this we have to subtract the top. So the top is also a pyramid, and this would be then 1/3 10 squared times the height, which we found to be 11. And if you plug this in the calculator, it should give you around 466.7. And don't forget to write the units, meters cubed. Oh, I forgot also to write meters in the first answer. So we need to make sure we have the units there. Finally, it says calculate the angle theta, the slant of the frustum. So they want us to calculate the slant of the frustum. Now, in order to do this, we need to know what this length is here. And we already know what the height is, so that way we can have a right triangle and just use inverse tangent. Okay, so I'm going to do C up here. So basically the first thing we need to do, again, is to find the base of the right triangle that we can see here, that is formed with the height and this distance here. So we need this distance. But notice that if you continue that line, this distance here, let's call it x, is half of the hypotenuse in this triangle. So that means that x would equal then the square root of 50 squared plus 50 squared divided by 2. And if you plug that in the calculator, it's going to give you something around 25 square root of 2. So once we have that, we have all the information required to find the slant. So the angle theta would be then equal to the inverse tangent of the opposite side over the adjacent. So the opposite side we know is 55, so it would be 55 inverse tangent of 55 over 25 square root of 2. So if we plug that into the calculator, it'll give us approximately a total of 57.3 degrees to 3 significant figures. Very well, so here we are now on question 12. And in question 12, they tell us that a trigonometric identity is a formula relating trigonometric ratios that is true for all angles theta. What they didn't mention here is that for right triangles, right? So this question is divided into 3 parts, A, B, C. So what we're going to do is that we're going to go over them one by one. So let's start with part A. So here we are with part A. And it says, using 30 degrees, 45 degrees, verify the following trigonometric identities. So verifying the identities just means that they want you to use the left-hand side to show that it is equal to the right-hand side. Okay? So, we know, let's start with 30 degrees on the left, and we will do 45 degrees in a bit on the right. So let's split this in half, the screen in half more or less. So with 30 degrees, let's do part 1, where they want us to prove the tangent of the angle is equal to that. So let's see, tangent of 30 degrees. So what do you get if you plug that in the calculator? If you plug that in the calculator and you go tangent of 30 degrees, you're going to get square root of 3 over 3. But we know that tangent is equal to sine over cosine. So that means that this should equal sine of 30 over cosine of 30. Okay, sine of 30 over cosine of 30. So what is sine of 30? Sine of 30, if you remember, is 1/2. So this is 1/2 over cosine of 30. If you do cosine of 30, that gives you square root of 3 over 2. And then if we manipulate this algebraically, what we're going to get is 1 over square root of 3. But remember that this is the same as square root of 3 over 3. How so? Well, if you multiply this by square root of 3 and this by square root of 3, right? Okay, so that's with 45 degrees, or with 30 degrees, excuse me. The other part that we have to prove is this one here, part 2. It says sine squared plus cosine squared equals 1. So for part 2, we would say then that sine squared of 30 plus cosine squared of 30 has to equal 1. Okay? So what's sine squared of 30? That's going to be 1/2 squared, right? Because sine of 30 is 1/2. Cosine squared, that would be plus square root of 3/2 squared. And if we square that, we're going to get 1/4 plus 3/4, and that equals 1. So for 45 degrees, it would be exactly the same thing. We would go, well, let's recall first of all for part 1 that tangent of 45 degrees equals 1. So that means that we have to get sine of 45 over cosine of 45 to give us 1 as well. But sine of 45 is 1 over square root of 2, or 2 over square root of 2, which is the same thing. And cosine is also 1 over square root of 2, and this inevitably gives 1. Then for part 2, we're going to do sine squared plus cosine squared. So sine of 45 squared plus cosine of 45 squared. And we can see that this is going to be 1/2 plus 1/2, which evidently equals 1. Okay, so here we are on part B, and it says using the triangle given, show that tangent of theta equals sine over cosine of theta, and sine squared of theta plus cosine squared of theta equals 1 for any angle between 0 and 90 degrees. Okay, so remember that if we grab this, right, this is theta here, so we know that tangent of theta would equal opposite over adjacent. So tangent of theta equals B over A. What we have to prove is that this is the same as sine of theta over cosine of theta. So if we do sine of theta, sine is opposite over the hypotenuse, and this divided by the adjacent over the hypotenuse. So then, if we calculate this, remember that when you divide, you multiply extremes and middles. So you can rearrange this as B times C over A times C. And notice that this would cancel out. Therefore, it equals B over A as we wish to verify. Now we need to prove that sine squared of theta plus cosine squared of theta equals 1. So what we can use there is a Pythagorean theorem, because we know that A squared plus B squared is equal to C squared. But sine is equal to B over C, right? So here we would have sine here. I'm doing it backwards, but that's okay. So B squared over C squared, this would be the same as sine squared of theta. And then A squared over C squared would be the same as cosine squared of theta. But because we're dividing these by C squared, we should do it here as well, C squared. And then C squared over C squared is equal to 1, which is exactly what we wanted to verify. So part C says that the identity sine squared plus cosine squared equals 1 is often called the Pythagorean identity. Using the work from B, explain why this is an appropriate name for the identity. Well, what we can answer here is precisely the fact that we used the Pythagorean theorem to come up with the proof. And it is the Pythagorean theorem that makes this true, so it's an appropriate name. Okay, so here we are with question 13, and it says the diagram shows the straight lines L1 and L2. The equation of L2 is y equals x. So L2, which is this line here, is the identity function, right? Y equals x. Y equals x. Then it says, letter A, find the gradient of L1. So this line is L1. L1. So remember that the gradient is equal to the difference in y over the difference in x. So we need two coordinates, but we have them right here on the graph. So one coordinate would be the y-intercept of L1, which is 0, 2. And the other point we can use, a coordinate, is the x-intercept, which is 6, 0. So using this, we can say then that the gradient is equal to the difference in y, that would be 0 minus 2 for y, and 6 minus 0 for x. So notice that this gives us negative 2 over 6, which we can simplify to minus 1/3. So that would be the gradient. In part 2, it says find the equation of L1. Now, because this is a line, remember that those equations are in the form of y equals mx plus b. And we already have m, and we also have b, because m, as we just found, is minus 1/3 x plus b, which is the y-intercept, and that was 2. So this would be the equation of the line. Now, for part B, which I'm going to write B here, so this was all part A, that was what we did before, it says find the area of the shaded triangle. So remember that a triangle's area is equal to 1/2 base times height. And we do have the base, which is very evidently 6, but we don't have the height, because the height is this point here, and we can't really tell exactly what it is. But what we can tell is that the height is the point where these two graphs intercept, so we can solve a system of equations. That means that I can use y equals x and y equals minus 1/3 x plus 2. We can use the system of equations to find that coordinate and therefore the height. So the easiest thing here is to use substitution, because y equals x. So let's rewrite this. Since y equals x, I can rewrite the second one as x equals minus 1/3 x plus 2. And then I can just solve for x, right? So we can say that x plus 1/3 x is equal to 2. And this implies that 4/3 x is equal to 2. And then let's just continue over here. That means that x is equal to 2 times 3 divided by 4, right? And we can simplify this and leave it as 3/2. 3/2. Now, because x equals y, that means that y is also 3/2. So that means that this height here is 3/2 or 1.5. We can see that that makes sense because it does seem to be 1.5, but we couldn't just guess that. Okay, so now we have everything necessary to find the area of the triangle, because it's going to be, A is going to equal 1/2 the base, so 1/2 times 6 times the height, which we saw is 3/2. 3/2. So let's leave it as 3/2 and see what happens then. So this is going to equal, and let's simplify here a little bit before we multiply. Notice that we can divide 6 by 2. So this is 3 times 3, 9 over 2, so 9/2, or 4.5. And they don't have any units, but you're expected to put something here as units, so you can say units squared. 4.5 units squared. Okay, so here we are on question 14, and it says that 75 metal spherical cannonballs, each of diameter 10 centimeters, were excavated from a Napoleonic War battlefield. Letter A, calculate the total volume of all 75 metal cannonballs excavated. Okay, so let's start with that. The first thing we need to remember is the formula for the volume of a sphere, and that is equal to 4/3 times pi times r cubed. So in this case, since the diameter is 5, that means that the radius, since the diameter is 10, that means that the radius is 5. So for one cannonball, we would have then that the volume of one cannonball would be 4/3 times pi times 5 cubed. But they want us to find the total volume of all the cannonballs. So this times the amount of balls, which is 75. And this, if we plug it in the calculator, is going to give us something approximate to 39,270. and we're talking about centimeters, so we have to use the units centimeters cubed. So let's write down, let me move this a little bit here. Centimeters cubed. So that would be part A. Now it says for B that the cannonballs are to be melted down to form a sculpture in the shape of a cone. Okay, so remember a cone has a circular base and is more or less like that, right? Horrible monument, by the way. So it says that the balls are to be melted down to form a sculpture in the shape of a cone. The base radius of the cone is 20 centimeters. Calculate the height of the cone, assuming no metal is wasted. So here we need to remember the formula for the volume of a cone. In the case of a cone, the volume of a cone is 1/3 pi r squared times the height. So using this, we can definitely find the height of the monument, because since the balls are going to be used and they're going to be melted down, that means that the volume of the cone is equal to the volume of all the 75 metal cannonballs. So that means that 39,270 is equal to 1/3 pi times the radius, which in this case of the cone is 20, so 20 squared times h. So now all we have to do is solve for h. So you could plug this into the solver and it should give you the correct answer, or you can do it manually. Let's do it manually here. So then we could just say that h is going to equal, let's be careful here because whatever is multiplying will be now dividing, etc., right? So this would mean that 39,270 times 3, because that's the only number that is dividing, right? Times 3, and this divided by pi times 20 squared. And then if we plug this in the calculator, it should give us then that the height is approximately 93.75 centimeters. Don't forget the units, guys, centimeters. So that would be the answer. Very well, so here we are now on question 15, and it says tennis balls with a radius of 2.5 centimeters are sold in pairs in a cylindrical can as shown. Letter A, find the height, h, of the can. Okay, so notice that the balls fit tightly in the can, so that means that the sum of the diameters would be the total height. Now notice that if the radius is 2.5, then this diameter is 5, and this diameter is 5, and 5 plus 5 would equal 10, so 10 centimeters. That would be the answer for part A. For part B, they ask us to find the volume of the cylindrical can. So that means that we need the formula for the volume of a cylinder. Remember that that formula is r squared pi, which is the area of the circular base, times the height. So that means that in this case, the volume would then equal the radius squared, so that would be 2.5 squared times pi times 10, and this is approximately 196 centimeters cubed. So let's not forget that it's cubed because we're talking about volume. Part C says find the total volume of the tennis balls. So the tennis balls are spheres. And remember that the volume of a sphere, just to recall, is 4/3 pi r cubed. So in this case, we have two balls, so we're going to have to multiply the volumes by 2. So that means that the total volume of the tennis balls would be 2 times 4/3 pi radius squared. So 2.5, radius cubed, excuse me, so 2.5 cubed. And you will see that that is approximately 131 centimeters cubed. Now for part D, they want us to find out what percentage of the can is filled with air. So what's filled with air? Whatever is left inside the can that is not filled by the balls, right? Now that just means the volume of the can minus the volume of the balls. So that should be the same as 196 minus 131. But they want us to find out what percentage of the can. So this is very similar to finding the percentage of error. We would do this subtraction and then divide this by 196, which is the total volume of the can, and multiply that times 100, and that'll give us a percentage. And if you do this, you will see that it is approximately 33%. Okay, so this is now question 16, and it says that a spherical statue is created by welding two hemispheres together with a metal band of length 12.56 meters as shown in the figure. Okay, so A says calculate the radius of the sphere. Now, when you think of spheres, when you put two hemispheres together, that means two half spheres, right? So that metal band, if you think about it, is going to form a circle. And the radius of the sphere would be equal to the radius of that circle. So basically what they're asking us is to find the radius of the circle that has a circumference of 12.56. So remember that the circumference formula is 2 times the radius times pi, right? So that means that this is equal to 12.56. Therefore, that means that the radius should be equal to 12.56 over 2 pi. And if we do that, we plug that in the calculator, we're going to see that the radius is approximately 2 meters. It gives us like 1.9999 something, but let's round it to 2 meters. So that would be the radius. And then for part B, once we find the radius, they say hence. Remember, whenever you see that word hence, it means use the previous information. Hence, calculate the volume and surface. So they want volume and surface. So we've done several volumes. Remember that the volume of a sphere is going to be 4/3 pi r cubed. And the surface area of a sphere is easy to remember because it's like 4 circles. So 4 pi r squared. Then just substitute for r, right? So we'd get 4/3 pi 2 cubed, and that is approximately 33.5. 33.5, but don't forget the units. So this would be meters cubed because we're talking about a volume. And then for the surface area, it would be 4 pi times 2 squared. And this is approximately 50.3 meters squared because this is an area, right? Notice that they also like to round to about 3 significant figures. So when you're wondering how to round, try to round to 3 significant figures. Very well, so here we are now on question 17, and they have this diagram with 2 triangles, and they give us several measurements. So let's say that AD is 4, AB is 9 meters, BC is 10 meters, so we have that there. They're telling us that angle BDA, this one over here, is 90 degrees, as we can see, obviously. And then angle DBC is 100 degrees. So we have 100 degrees. Calculate the size of angle ABC. So they want us to find the size of angle ABC. Now remember that when you look at angles, you start with A, so this is point A, and then B. So that means that they want us to find this entire angle, right? This entire angle there. But we're missing a little piece here. Let's call this piece here theta. So we could say that ABC, angle ABC, is equal to whatever theta is plus 100 degrees. So we can find theta using this right triangle that we have here. Now notice that theta is equal to the inverse sine of opposite over hypotenuse, right? So 4/9. And if we plug this in the calculator, it's going to be approximately 26 degrees. That means then that angle ABC is equal to 126 degrees approximately. Now that's rounding it nicely to three significant figures again. Okay, so once we have that, it's easy to find AC, this distance here, AC, because we have all the information we need to use the law of cosines. So if we want to find the length of AC, let's remember that AC squared is equal to 9 squared plus 10 squared minus twice times 9 times 10 times cosine of the opposite angle, right, which we just found, which is 126 degrees. That means that AC would be equal to the square root of all this. And if we plug that into the calculator, we're going to find that it is approximately 17.0 meters. Notice again the rounding to three significant figures. Okay, folks, so here we are on question 18, and it says figure 4.46 shows a triangle ABC in which AC equals 17 centimeters. So this distance from here to there is 17 centimeters. M is the midpoint of AC. Notice that if it's the midpoint, that means something, right? That means that it cuts this side AC in exactly two equal lengths. So that means that AM is going to be 8.5, and so is MS. MS is also going to be 8.5, half of 17. Triangle ABM is equilateral. Okay, so that means that all sides of ABM are going to be 8.5. Now that is going to answer this question right here, because they want us to write down the length of BM. But because we already know that triangle ABM is equilateral, that means that BM has to be also 8.5 centimeters. Okay? The size of angle BMC. BMC. Okay, so BMC would be this angle over here. Now, because ABM is equilateral, we know already that this is 60 degrees. Because in an equilateral triangle, all the angles and all the sides are the same, right? So all the angles are 60 degrees. And in this case, all the sides are 8.5 centimeters. So because 60 and this other angle that is next to it, right, the angle they're asking for, BMC, they have to add up to 180. That means that BMC has to be necessarily 120 degrees. Now it asks for angle MCB. So MCB is this angle. Now, let's redraw this over here so we can have a clearer picture. So we have something that looks more or less like this. And this is B, this is C, and this is M. Now we know that this length and this length are the same. They're both 8.5. So that means that this is an isosceles triangle. And in isosceles triangle, you're going to have that this angle and this angle are the same. Since we already know that BMC is 120 degrees, that means that we're only left with 60 degrees, right, for the total of 180 inside the triangle. But because it's isosceles, it means that this has to be 30 degrees as well as this. So that means then that MBC, or MCB, excuse me, MCB is 30 degrees. Okay, so once we've have all this information, we can calculate the length of BC as well. Because BC, applying the law of cosines, we know that BC squared is going to equal 8.5 squared plus 8.5 squared minus 2 times 8.5 times 8.5, that's same as 8.5 squared, times the cosine of 120. And that means that BC would equal the square root of all this. And that is approximately 14.7 centimeters. Very well, so here we are on problem 19. A car drives 80 kilometers from city A to city B on a bearing of 0, 70 degrees. So let's start with that information. Remember that when they talk about bearings, we need to have a vertical line, a nice vertical line that goes north to south or south to north, however you want to look at it. So if we have city A here, we need to measure the 70 degrees from A to B right over here. So this is going to be 70 degrees. And then it says that from A to B, the car drove 80 kilometers. So this is going to be 80. Let's just write 80 for now. Then it says that from city B, the car drives an additional 200 kilometers directly east to city C. So the east would be the right. So we go east 200 kilometers to city C. So this is 200. I'm not going to write the units for now. And you'll see why in a bit. Okay, I'm also going to write city B here on top. And I'm going to get rid of this here. So, part A, calculate the distance between city A and city C. So they want us to find this straight line, right, from A to C. What is that distance? That would be part A. So notice that here we need to use something like the law of sines or something like the law of cosines. But we need an angle. We need this angle B. But that's easy to know because since this is 90 degrees here, right? Meaning that straight east would be 90. And if you add 70 to that, that's 160. That means that this angle here is 160 degrees. How so? Okay, let's think about it this way, just so everybody is clear. So let's draw an imaginary parallel line to this one over here. So we have, what happens when you have two parallel lines that are crossed by another line, like this one. So if we have two parallel lines and it's crossed by this other line, you have something called alternate interior angles. That means that this angle here would also have to measure 70 degrees. And this one's a right angle, which is 90, and we know that 70 plus 90 is 160. So therefore, this is 160. Okay. So once we have that verified and clear, all we need to do is apply again the law of cosines, because we have the two sides that are the two sides apart from AC in the opposite angle. So again, remember that AC is going to equal, and I'm going to start just writing the square root of right away. So AC is going to equal the square root of 80 squared plus 200 squared minus 2 times 80 times 200 times the cosine of 160. Very well, if you plug this into the calculator, it's going to give you approximately 277 kilometers. So that would be the answer for part A. Now, in part B, they want us to find the bearing from A to C. Now, the bearing from A to C would be all this angle, all of this angle. So we already know that this is 70 degrees. That means that we need to find this. We need to find this. Let's call this theta. In this case, we will have to use the law of sines. Remember that the law of sines would allow us to do this. We would know that sine of theta divided by 200, the opposite side, divided by 200, has to equal or is proportionate to sine of 160 over what we just found, 277. So with this, and we can plug this just in one stroke in the calculator. With this, we can solve for theta, because theta would then be the inverse sine. And to get more accurate answers, you want to plug the whole thing in. The way it is, not solve all these things independently and then put them together. So it would be the inverse sine of sine of 160 times 200 divided by 277. And if you plug that in the calculator, it's going to tell you that theta is approximately 14 degrees. That means then, to answer B, that the bearing from C to A would be 70 plus 14. In other words, the answer for B, and I'm going to write it over here, for B, the answer for B would then be 70 plus 14, 84 degrees. Okay, so we have finally arrived to the last question, question 20. And it says, in a factory, contaminated water is pumped into a cuboid-shaped container with dimensions 20 times 18 times 6 meters at a rate of 0.4 meters cubed per second, where it is purified. And we see a drawing of the cuboid. And it says, find the volume of the cuboid container. Now, the volume is simply going to be multiplying 20 times 18 times 6, which are the dimensions of the cuboid. And this is going to equal 2,160 meters cubed. Now, B says, calculate the time required to fill the container correct to the nearest minute. So, because it has a rate of 0.4, we could find how much time it required to fill it by dividing 2160 by 0.4. And this is going to equal 5,400 seconds. But they want the answer accurate to the minute. Remember that there's 60 seconds in 1 minute, so let's divide this by 60. And if we divide this by 60, that equals 90 minutes, which is the same as 1 hour and 30 minutes. Now be careful with minutes because it's M-I-N, not M, which would be meters. Okay. Let's go to part C. So part C says that the inner surface of the container is to be covered with an anti-corrosion spray. The opening of the container is a circle with radius 0.1. Calculate the surface area to be covered with the spray. So the surface area is really the sum of the different rectangles, right? So notice that we have two rectangles that are 18 times 20, right? 18 times 20. Now that's this side and the opposite side of that, plus another two rectangles that are going to have dimensions 18 times 6. That's going to be this one and the other side. And then we need the top and the bottom. And that would be also two rectangles. And these would have a length of 20 times 6. So if we multiply all this, it's going to give us the surface area. And you're going to see that it's 1,176 meters squared. Okay, so now we're left with D. So we're going to do D over here to the left. And it says, after being purified, the water is pumped into a pond that is approximately cylindrical. with a diameter of 80 meters. Okay, so if we have a cylinder, sorry for the drawing, but you get the idea. So if it's a cylinder of diameter 80, that means that its radius here would be, the radius would be 40, and we need the radius to find this. How much does the height of the pond increase by adding the water from the container in centimeters? So they want the answer in centimeters. Okay, so the radius is 40 meters. Since we know what the volume is, we can use the volume formula, right? Because the volume of a cylinder, as you recall, is pi r squared times the height. The volume of water we already know from question A, because it's 2160 meters cubed. So 2160 has to equal pi times r squared, so 40 squared, times h. So we can find the height by simply dividing 2160 by pi times 40 squared. And you're going to see that this is approximately 0.429 meters. But they want the answer in centimeters. Remember that there's 100 centimeters in a meter. So if we multiply this by 100, we're going to get 42.9, or approximately 43 centimeters. Okay, guys, so that would be it for this video. Remember that we will have a quiz that I'm opening on Friday, right, or midnight Thursday until Sunday. I'm going to be changing a few things so you guys feel a little bit more comfortable with the quiz, and I'm sure you're going to do great. So best of luck to you all.